Ever wondered what a file on your computer really is? We talk about them all the time: documents, photos, videos, but what are they fundamentally? Today, we're going to demystify the file, and we will use a simple analogy that will change the way you see your computer forever. A massive, bustling logistics warehouse. Let's start with the basics. Imagine every single file on your computer is a sealed cargo box. That's it. A simple, sturdy box. What's inside? Data. It could be the words of your novel, the pixels of a photo, or the code for a program. The box itself is the container holding all that raw information together in one neat package. When you create a new document and start typing, you're essentially filling a new box with letters and words. When you take a picture, your camera fills a box with a complex pattern of colors and light. The box keeps everything organized and separate from all the other data. So if the file is the box, what's the file name, like myvacationphotos.jpg? That's just the label slapped on the outside of the box. Think about it, in a real warehouse, you wouldn't know what's inside 1,000 identical boxes without labels. The file name is your way of telling the system, and yourself, what this specific box contains. It's a human-readable identifier. You can change the label anytime you want, right? You can rename Vacation Photos to Summer Trip 2024. Does changing the label alter what's inside the box? Of course not. The data, the actual contents, remain completely untouched. This is a crucial concept. The name is just a pointer, a convenient reference, not the thing itself. Now let's get a bit more advanced. Every package in a real warehouse comes with a shipping manifest or a detailed information sheet. On your computer, this is called metadata. Metadata is data about your data. It's the manifest attached to your cargo box. What kind of information is on this manifest? Things like the size of the box, how much data is inside, measured in kilobytes or megabytes. It includes timestamps like when the box was created, when it was last opened, and when it was last modified. It also lists permissions: who is allowed to open this box. Can they just look inside, or can they change the contents? This metadata is vital for the operating system, the warehouse manager, to handle the file correctly. When you right-click a file and go to Properties or Get Info, you're just reading the manifest for that specific box. Okay, so we have thousands of these labeled boxes with their manifests. If you just dump them all on the warehouse floor, it would be absolute chaos. You'd never find anything. That's where directories, or as you know them, folders, come in. Think of directories as the organizing system of the warehouse. The main C drive or Macintosh HD, that's the entire warehouse building. Inside you have large sections like program files, users, and windows. These are the main aisles or zones. Then, within your users section, you have your personal area. Inside that, you create folders like documents, pictures, and downloads. These are like specific rows of shelves or even individual shelves in your designated area. When you put a file into a folder, you're not physically moving the box to a new location in the computer's memory. You're simply updating the warehouse's central inventory system to say, the box labeled My Resume is now located on shelf 3 in the Documents aisle. This hierarchical structure of folders within folders allows for a logical, efficient way to store and retrieve millions of files without everything turning into a complete mess. It's all about creating a path, a clear address, for every single box. So let's recap our warehouse. The file is the sealed box of data. The file name is the label on the box. The metadata is the shipping manifest attached to it with details like size and date. And directories or folders are the warehouse sections and shelves that keep everything organized. This analogy holds up surprisingly well for almost everything you do with files. When you move a file from one folder to another on the same drive, are you really moving that big, heavy box? No. In most cases, you're just quickly updating the inventory log. The system just changes the location entry in its master list. The box itself hasn't budged. This is why moving files within the same drive is almost instantaneous, no matter how big the file is. You're just changing the label's address, not physically relocating the data. However, when you copy a file to a different drive, like a USB stick, you are actually building a brand new, identical box and filling it with the exact same data in the new warehouse. That takes time, because you have to read all the data from the old box and write it into the new one. Now for the big finale, the question that ties this all together. What happens when you delete a file? Let's say you drag old project.docs to the recycle bin or trash. Have you just incinerated the box and everything inside it? not exactly. When you perform a standard deletion, your operating system, our trusty warehouse manager, does something very clever and efficient. It doesn't waste energy destroying the box. Instead, it simply walks over, rips the label off the box, and throws the label away. The box, with all its data still inside, is still sitting there on the shelf. The system then updates its inventory and marks that shelf space as available. To the operating system, and to you, the file is gone because it has no label and no official location. It's invisible. But the data is still there, at least for a little while. This brings us to file recovery. Why can you sometimes get deleted files back? Because you're using special software that ignores the main inventory list and goes row by row, shelf by shelf, looking for any boxes that don't have a label. If it finds one, it can try to reconstruct the manifest and stick a new label on it, making it visible again. Voila, your file is recovered. But there's a catch. Remember how that space was marked as available? If you continue to use your computer and save new files, the system might need that shelf space. It will say, an empty spot, and it will put a new box right there, overwriting the old, unlabeled one. Once that happens, the original data is truly gone forever. That's why, if you accidentally delete something important, the very first thing you should do is stop using the computer to prevent that data from being overwritten. The longer you wait and the more you do, the higher the chance your old box will be replaced. And what about emptying the recycle bin? That's like telling the warehouse manager, okay, any boxes whose labels are in this bin, go ahead and officially mark their space as empty and available for new stock. It's the final confirmation. A secure delete or shred function is different. That's like telling the manager to not only remove the label, but to also take the box, shred its contents, burn the pieces, and then scatter the ashes. It's a process that actively overwrites the data with random nonsense, ensuring it can never be recovered. So the next time you save, rename, move, or delete a file, picture that bustling warehouse in your mind. You're not just clicking icons. You're directing a massive logistical operation of boxes, labels, and shelves. Understanding this simple analogy doesn't just make you sound smarter. It gives you a real, intuitive grasp of how your computer manages your most precious data. I hope this little journey into the digital warehouse was helpful. If you enjoyed this explanation and want more deep dives into how technology works, make sure to hit that like button and subscribe to the channel. Let me know in the comments what other tech concepts you'd like me to break down. Thanks for watching, and I'll see you in the next one.